Hey everybody, hope you're doing okay. This is Mr. O. We're getting ready to start our new unit or our review unit of linear functions. I know I'm not here this week, but we will have 3 assignments of notes and then we will have 1 performance assignment on Friday. You'll have a video like this every day to watch as we go through and we'll work it through together and talk about it as best we can as a class. So let's start today by writing down our topic and essential question. Today, our topic is arithmetic sequences. And our essential question is, how can we graph and write equations for arithmetic sequences? For this note sheet, we're going to talk through problems together one at a time, and then you'll get a chance to practice on your own, and we'll do some quick notes and stuff on the back. That being said, let's dive into our scenario. In the first month of a new startup's operation, the company has only 4 employees. Each month, the CEO hires more employees to keep up with the growing business. By the second month, there are 7 employees, and by the third month, there are 10 employees. The CEO keeps hiring according to this pattern. So what I want you to do is I want you to take a second, pause the video, and then I want you to answer questions 1 and 2 on your paper. Go ahead and pause it, and we will be back together in about 5 minutes. All right. Now that you've hopefully answered our questions, let's go ahead and let's check our answers. So, we need to start by filling out our table. And we see that in the third month, there are 10 employees. So we can go ahead and fill that in for month 10. Now, hopefully at this point, you've started to notice a pattern. We go 4, 7, 10. In month 4, we have 3 more employees, taking us to 13. Now, I want you to notice there's a change here that happens between our next line. We go from month 4 to month 6. So instead of just adding, we have to do whatever our pattern is, and we have to do it twice. So to go from 4 to 6, we add 3 twice to get us to 19. And then we see to get from 6 to 11, we have to add 3 5 times. So we go 19, 22, 25, 28, 31, 34. What we see happening here, go ahead and make these notes in a different colored pencil, is every month the number of employees jumps up by 3. And then even though we didn't jump up by 3 here, since we went 2 months, we jumped up by 3 2 times. This is a classic example of what's called an arithmetic sequence. I know it's an E there, but we pronounce it like an A, arithmetic. So let's answer question 3 or 2. How does the number of employees grow from month to month? We've already seen it increases by 3 every month. So we can say 3 new employees are hired each month. We have a special name for this plus 3. This plus 3 is what's known as our common meaning the same, difference. We say our common difference, or our D value, is equal to 3. All right. Let's go ahead and let's work problems 3 and 4 together. Let's do those next. I'm going to give you 5 minutes. Go ahead and take 5 minutes to answer problems 3 and 4. Go ahead and pause the video. All right. Hopefully we're back. Let's go ahead and let's talk them through together. So problem 3 asks us to plot the number of employees in each month on the graph below, and then it asks us what we notice. So they already did month 1 and month 2 for us. In month 3, we have 10 employees. We can put a dot there. Month 4, we have 13. There's not an exact spot, but we can get it close. Month 6, 19. And then month 11, 34. What I want you to notice is that all of these dots look like, if I kind of connect them together, they form a straight line. And hopefully that was what you answered for question 3. They go up in a straight line. We have a special name for graphs that make a straight line, and it's a real easy name to remember because our name is linear, literally line and then an AR at the end, linear. This is an example of a linear graph. Now, question 4 is kind of interesting. Assuming the pattern continues, how many employees will there be after 2 years or 24 months? How do you know? Now, some of you might have handled this a couple different ways. Some people might have said, okay, I know I start with 4. Start with 4 employees. And then we go for 23 months. And then we're going to add 23 times. We want to put that in kind of an equation. It would look like 4 plus 3 times 23. Put that equation in, do our math, and it's going to give us 73 employees. Maybe you did it another way. Take a second. If you did it another way, share that strategy you used with a partner nearby or share it to the class. What I want to be crystal clear about here is our 3. We didn't multiply it by 24. What we did instead is we took that 3 and we multiplied it by 23. This is the same thing as 4 plus 3, parentheses, 24 minus 1. Same equation. Last but not least, let's talk about number 5. Can you write a rule that will give the number of employees after n months? Check to make sure your rule works. So this is kind of like the problem we just solved, right? Except this time, instead of giving us a number of months, they just give us n. So in theory, we can take this equation, 4 plus 3, parentheses, blank, minus 1, and instead of filling in the number of months of 24, we can just fill in n. And then we can rewrite this equation using our distributive property. So let's distribute that 3. This is going to become 4 plus 3n minus 3. And then we look and say, okay, I've got my 4, my minus 3n. These can combine because they are like terms. So I can take 4 minus 3. It's going to give me 1. Nothing happened with that 3n, so we can put that at the front. 3n plus 1. And there's our equation. go ahead and take a second and use this equation to figure out it and check it by looking back at your table and plugging in the number of months. If you plug in 1, you should get 4. If you plug in 2, you should get 7. All right. Now, let's go ahead and let's look at our quick notes on the back of your page. Today, we learned that arithmetic sequences have a common difference. That common difference describes how we change each entry. We change them by adding or subtracting the same thing every time. Arithmetic sequences, if we like to graph them, they form a special type of graph, which we say is linear. Arithmetic sequences are linear. And we can write a formula in the form AN, the arithmetic sequence nth term, is equal to A1, the first term, plus my common difference times n minus 1. We can then rewrite this by distributing my d and then doing some subtracting to get an equals dn plus a to the 0, where a0 is your 0th term. My tip, start in this form and then distribute to get here. I should say A1 is your first term. And D is your common difference. Okay. Let's do some of the problems in the check your understanding. Let's start with number 1. If you have a rewards card at Bixby, you earn a free drink after every 12 drinks you buy. Can the total amount of money spent at Bigby after ordering n drinks be considered arithmetic? Why or why not? Go ahead and pause the video and talk about it with a partner, and then we'll come back together. Okay. Y'all were probably split pretty evenly between yes or no's. The answer to this question is no. Even assuming you buy the same drink every time, you know, even if you buy the same drink every time, it's not enough. This is not arithmetic, because even if you drinks 1 through 12 cost $2 a piece, what's going to happen on drink 13? You earn a free drink. If we were going to put this in a graph, this would probably look something kind of like this. You slowly go up, and then you take a stair step. And you slowly go up, and then another stair step, right? Every 13th drink is free, so it doesn't end up costing the same every time. The problem is the free 13th drink. All right, let's look at our next one. Number 2, determine Whether each sequence has a negative common difference, clearly explain your reasoning. So what we're looking for is a sequence that goes down, and it goes down by the same amount. Go ahead, talk as a class, and take 5 minutes to decide which one of these have a negative common difference. All right, now that you're back, let's go ahead and let's work it out. Sequence number 2, let's look at A first. We can see for sure it's going down. But if we look at the first 2 terms, we're going down by 32. Second 2 terms, we go down by 16. And then we can already see it's not the same amount. This is going to be no. We go down by different amounts. Looking at problem B, the daily odometer reading on a car after driving 15 miles every day. So we're happy if we drive 15 miles every day, it's automatically going to increase by the same number. But we forget the second part. It needs to go down. This is not good because it has a positive common difference. Let's look at C. We can see clearly our graph is going down, but in order to have a common difference, we need it to be linear. This graph is clearly not linear. So this is also a no, because we are not linear. Last but not least, let's look at problem D. As we go through, we are going down. We go down by 5. Down by 5. Oh, we go down by 10 here, but it's okay because see how we jump 2 months? It's like we jump down -5 2 times, -5. So our only one that's a yes is problem D. Our common difference is -5. All right. Last one for today. A family cell phone plan is sold for $35 a month for the first line, and then $20 for each additional line. Write an explicit plan, a formula, for the monthly cost of the plan for yourself and N users. Take a second and give this a shot. All right, now that you're back, let's talk it out. So we can always start with our AN, our general formula. AN equals A0 plus DN minus 1. Or sorry, A1 plus DN minus 1. We know A1 is that initial term for that first user. Our problem tells us the first user pays $35. So we can say AN equals 35 plus 20, because our D, our common difference, is what we're adding for each line. In this case, it would be 20 times N minus 1. And that would be our formula. Okay, great work today, everyone. I hope you learned at least a little bit. What I would like you to do for the rest of class today is go ahead and fill out your summary on the page. Once you are done with that, please put this in your math notebook, and then the rest of class is yours to quietly work on whatever you need to. Have a wonderful day, and I'll see you tomorrow for our next video.